Why don't we get started and students will anyway continue joining in. Let me introduce Apur, folks. Maybe I'll do the first professional introduction, but also I found out a bit about him, catching up with him. So Apur has a deep interest in DSA, something he's had since college. And then he actually saw it getting applied in the real world, especially as part of the work he's been doing at Walmart. Apurv is currently part of Oracle. Many of you may have heard of Oracle in the context of databases, but Oracle also has a cloud. Apurv, you can correct me. I believe Oracle is probably the fourth largest cloud after the big three,
Yeah, right.
Amazon, Microsoft, and Google. So,
Uh,
Apurv,
Microsoft, Google, Amazon. After that, yeah, fourth largest.
Aisha, you see, Microsoft is bigger than Amazon now, cloud-wise?
No, no. Amazon, Microsoft, Google, and then
Correct, Oracle, OCI. So this is the fourth largest cloud environment, and Apurv is part of the logging, authentication logging infrastructure team. Essentially, all across the Oracle Cloud ecosystem, whenever, wherever anyone logs into any system, all of that data feeds into the systems that Apurv works on. And then this data is used to do analysis like, is there any attacks happening, any fraud, any deviation from regular kind of a framework. I hope I captured your work broadly, right, Apurv? Welcome. You've been out of college for a few years now, and you have seen how all of the data structures, algorithms, the kinds of problem statements we typically end up, learning in undergraduate education. But sometimes it's not easy to see how it will be applied in the real world. Many students say that maybe I'll just Google it at that time. Right? What's the point of learning or understanding it in depth? Anyway, there's Chat GPT and others. Whenever I need something, maybe I'll just use it there. So perhaps you can shed some light on what are some use cases where you actively applied it, and how should all of our students think about the fact that problem solving in itself is a skill, and how much does Chat GPT and similar uh, AI help work. So with that, I think you have a whole session planned. Apu, over to you.
yeah, sure. Yeah, Chat GPT is a major disruptive tool. So yeah, it has, I mean, changed the game. I'd say, yeah, it can help you in most of the cases, but it still makes errors, and it's easy to get solution. It's harder to debug if you go into error. So it's good. I mean, there are lots of AI coming now, like Claude AI and Llama, and all of them, they all are doing really well. Like benchmarking of Claude AI is better, like in some of the rankings for coding as at least. So yeah, these things are working really well, but I would say that these things will not like help you grow. They are still in development phase, and they will eventually get better and better. But problem solving is something that you yourself would have to do, because lot of problems, it there are lots of complex structures involved, and each of those components involved, you cannot like put all the details that is possible, that is only understandable to you. Like you'll have months or years of knowledge that how your system works. And if you come across some issue that may or may not, chat gpts and these may or may not help you. So I would, sorry. So yeah, first I will like to go on the DSA and its importance in real world. So first of all, how many of you get intimidated by DSA, like when you hear competitive programming or these things? Like you can give some thumbs up or know how you feel about it. Okay, I'll assume that you all are like at some level you must be feeling the pressure, but yeah, that's kind of it is how it's in college. While I was in college, it was confusing to me as well, like DSA, like trees, recursions, dynamic programming. But with practice, yeah, it all came together. So I would like to the message that I would like to give, that problem solving and understanding how it's important. DSA is important to solve problem, and software system how it works at scale. You need DSA for that. Like you may not have practical uses daily, but in optimizing process, tackling large data sets, or creating new systems. So underlying principles are of DSA only. Like for example, how you should know at least the algorithms, how they work. Is it sorting algorithm or some graph algorithm or hash map, hash tables? All these things you should be aware how they work in order to at least Google also like which one to use. These things will help you understand better the system. So while not always directly applied, but DSA teaches you structured thinking and foundational knowledge to building a scalable system. So now I'll get to a case study of how at Walmart I was one of the challenges that I got and how we solved it. I'd like to make it interactive, so you can answer in the chat or through emojis, however you feel like. So I'll give you a problem to think about. So uh, in Walmart stores, the application that we were working on was used by store associates. So you can assume like how it's in Amazon here. You have a data like a warehouse where you have lots of orders, parcels coming in. So before that, how Walmart is a store like I would rather pick example of Big Bazaar. That's a superstore. It has everything, and these store sizes are huge. And you have store associates who gets a list of order from multiple people might be ordering like they need 10, 20 items, all of them. So how do you decide from a starting point that I have to pick this 20, 30 number of items? I have to go across the store, some maybe at the end of the aisle, left, right, any direction it is there. And you have to efficiently pick all the items in an order and reach a stage where you can just put the basket down in the staging area. So you have the coordinates of all the aisles where all the items are kept, and you have a list of orders. So it may happen that you go for something snacks in one section, then some electronics item in the other section, and you have to travel back and forth. So what algorithm would you suggest would be efficient one in this case that can help you find efficient path? Any guesses, students?
Dijkstra's algorithm, sir.
Yeah, yeah. Yeah, that's right. A variation of Dijkstra algorithm we can use. Dijkstra will work, or Floyd Warshall will work because multiple like points we have to reach. So all the points distance we need. So yeah, that's one of the case where you can see the direct application of these algorithms we got. We while may not be like you may not get every day, but yeah, this is like a core principle how the system works, how you pick the items and how those items will are picked by store associates and then put in the end for future like steps involved like packaging, generation of shipping labels, shipping, these things. So this is one of the case where you see the use of DSA in real life. And other, let's take another example. Okay, or in this example only, let's continue. So the store associates, how do they like know that, okay, now I have to pick some items? Okay, if I have picked the other one who is at the end, once the items are picked, he has to carry that basket and put it in a box or in a bag if the customer wants to come pick up from the store, and then like do the packaging and generate a shipping label, stick it on the box, and then say, okay, the order is ready to be shipped. So these things are flowing, and imagine the scale like in millions. So what data structure do you think would be efficient or effective in this case in order to handle all these flowing events? Like, okay, now order you have picked, it's okay. Now you have some more orders ready to be picked, or there, okay, some orders are ready to be staged. It is ready to be packed. So how do you imagine this volumes of events flowing in the system? What data structures would you recommend? Any guesses? It's a very simple one. So, okay, do you want to make more guesses? Anyone? You can make guesses. It's okay, right or wrong. So the answer is it's queues, right? So you have list of or events flowing across. So how do you want it to be? You want it to be in queue. Like once for a order, it if it is item is to be picked, you have picked it. Now the item is ready to be staged. It's put in staging area, and then the next step would be to do the packaging, then the next step to generate the shipping label and then ship the item. So it's all part of a queue. You'd want the events to be flowing in one order, and all of these like multiple orders will be flowing in a queue, which we use the data streaming tool like Kafka. But essentially like inside of it, it's queue only, like it's distributed queues, but yeah, you have the basic data structure is queue. So this is how you see like these data structures come into technology, and they build framework around it so that you can use it more efficiently or effectively. So this is another use case that I wanted to share related to data structures and algorithm. uh, Next I'd like to move to, before moving, so do you have any thoughts or questions? Okay. So the message here, the message will be that you do not need to learn all the algorithms. Like you do not need to memorize or like I don't know most of the algorithm. I just know how they work, but I do not have them memorized. But you need to understand how to approach problems algorithmically. Like that's how we learn concepts and apply them. Or I would advise you to that you'll apply them to a side project of your own so that you can learn how these things work. So yeah, that's part one of my topic. The part two is critical thinking in action. This was one of the other topic. So can any of you like suggest what critical thinking is? How do you define critical thinking? Anyone? How do you think? What is critical thinking? Yeah. Okay. Okay. Or yeah, Jay. Yeah, you can go ahead. Okay, no problem. So how I like to put critical thinking is a systematic way of approaching a problem or breaking complex problem into manageable parts, analyzing them, crafting solution. So I'd like to frame it that way. And critical thinking is actually important because these are used in for interview point of view as well, like in behavioral interview and system design challenges. So critical thinking is important. Like you should know what component you are putting in a system, why it's important, how will that scale, or for example, uh, or at least in behavior as well, like what was your thinking behind a problem you solved or how you approached the problem. So these things are important, and so you should focus on this as well. It's important for interview point of view as well, and also for in general problem solving. Okay, so for this also I'll take example of one of the startups that I had worked shortly. So how do you build a system, automated parking system? So we were with the challenge of building an automated parking system. So you all can like type or speak out. How do you build a parking system that's fully automated? And before, like I'll give you a sense what was the uh, founder's goal, or how we wanted the solution to be. Like uh, you, how many of you use AirPods? Yeah. Okay. Any earphones or Bluetooth earphones, right? So imagine how the experience it is like when you open your the box of your earpod. it automatically connects to your device. You put it in your ears, it gives you noise cancellation. You did not do like any cognitive work. That cognitive work was not involved. You just took it out, it got connected, you put it in your ears, and you are having a nice noise cancellation without doing any manual adjustment. So that's a kind of technology that we want. Like, it's an invisible technology that you don't need to think about it, how it works and how the internals are doing. You do not have to interfere. Or if, for an example, like when you're approaching a automated door, you do not think like I have to open the door, right? You just go towards it and it opens. So it's like that kind of invisible technology around. So so I'd like now you to brainstorm. Let's say you are given a problem that you have to build a system. Just think about it. How do you want this system to be, or and how can you achieve that? Anyone, if you have any thoughts on that? It can be very basic. It's okay. You can give your thoughts if you have any. Okay, then if not, then I will only explain how we did it and how we try to solve it. So if you observe the current experience you would be having at any parking mall in, like, let's say Bangalore only. So when you go to a parking mall, there would be some person who would hand you over a card. Okay, you take this, and then a barrier that would open. You can go in, and then you do whatever you want. You want to watch movie, have fun in mall. You come back, then again you hand that slip back to that person. They will calculate the bill, charge you. They will pay whatever you're taking, like via online or cash, and then they will open the barrier, and then you go. So there's a lot of hindrance involved, and what we were trying to solve here is that how to make it invisible. Like, it should be a subconscious experience. So how we did it, like if a user is going at a, let's say, 20 kilometer per hour speed, they do not need to slow down also, so they can just keep moving. And when they approach the uh, that boom barrier area, it will automatically open, and they can go and park anywhere. Then at the time of exit, they can again just go towards the exit area. The barrier would open and they would leave, and the bill would be sent to their credit card. So how this would be something that would be a nice experience, right? You did not have any interaction, especially after COVID, where you do not at the time of COVID, when you didn't want any physical interaction, like physical touch or handing of cards and all. So it was during that time of my career when we were doing this. So how did we achieve this? So what we did was we put a automatic number reader camera just a few meters before the uh, boom barrier. So that camera captures the number plate, and it will automatically allow you to enter the barrier. I mean, the barrier will open and you can go and park. And at the time of exit, you can again, when you'll go back. So we have created a session for that customer or user. So when they entered with their number plate as their unique identification. So we had few other methods also like RFID. That also works, but that needs a installation of sticker. Then it works. Otherwise, just the number plate reader camera works, and then you can just go in, and at the time of exit it would read again and then open it for you, and the user can exit. So this was one of the system that we built for automated car parking solution. So here we
Maybe there was a Apur. Are we sharing your screen by any chance?
uh, no, I am do not have it like
Oh, I see. Okay,
I have notes, but not share worthy. So
no worries. Okay, then perhaps you can continue. I thought maybe you were referring to something, so just in case the context was missing, please proceed.
okay, yeah. So that's a high level design, because yeah, I did not introduce like design things, so that's why I just kept it verbal. Uh, so yeah, that's one of the critical thinking projects that we did. So yeah, so these are the real life use cases where you can think about a solution, then brainstorm how to do it, and then just build a system around it. So it's So it's an example of how you do it in real life. So this is one of the examples that I had. So any questions? It's okay. Yeah, that's all I had from critical thinking part. I actually had a few questions for students to ask from the data structures algorithm part from the first part. I just quickly ask them if so that I get some kind of interaction. Uh, so how many of you are on social media like Facebook, Instagram? Just give a thumbs up. Okay, so you would have seen how the social media works. Like Facebook is different to Instagram in terms of making friends, right? So when you send a friend request to your friend, if they accept it, you become friends, like both of you become friends. But on Instagram, if you send a friend request to someone, they accept, so they just follow you, right? They have to send a separate request to you to like follow back. So then you accept, then they are able to also view your profile and everything. So if you imagine, so there's a network of people, you can say it's a graph, and all of these peoples are connected. So in Facebook, if you connect two of these people, so what kind of graph would you say it is? Like how different this graph would be compared to an Instagram graph? Yeah, right. So which one would be directed one? Think, students. So in Facebook, if you make a friend and the friend accepts it, whomever you send the request, you both get connected, right? You both can view each other's profile. So should that be directed or undirected? Compared to Instagram, where if you send a request to someone, only the friend you sent, that one, only you are able to follow them and view their profile, but they are not. So actually, in Instagram is an example of a directed graph where whoever you follow, only you can view their profile. They need to follow you back, and you need to accept in order to them to see your profile, right? So yeah, Facebook is undirected, and Instagram is an example of directed graph. So when both of them accepts, then becomes two-way arrow. So kind of undirected in that case. But yes, still you can, and someone can unfollow, and then it can again become a one directional graph. So yeah, this is one of the questions I wanted to check. So this is also a real life example of how these data structures algorithms work, and they can help you understand another term like mutual friend. So how do they figure out who is mutual friend? Right? They have this list and then check both the list. So the intersection of the list becomes the mutual friends. Similarly, in LinkedIn, have you seen that first connection, second level of connection, third level of connection? What kind of data structure do you think that will be? Or rather, which is more appropriate data structure to show that kind of structure? Any guesses? It's a tree structure, right? So you have one person at the top, and it can have several first level connection, and then all the first level connection can have several second level connections, and then the third level can have all the second level can have their own connection that will become the third level for the first person. But you see, this tree grows very large, so maybe that's why they I think they can increase the number of levels as well. But yeah, so you see the how this tree grows every time the levels get increased. Are you trying to, are you able to yeah, visualize that? Okay. Okay, thank you. That's all I had my content to discuss about. I had kept it like 30 minutes so I can have some questions. Okay, I have one question. So first question is how to compete amongst peers on DSA?
Right. So we collected some questions upfront. I've also opened up the Q&A. I'll ask Dharin to moderate the Q&A, please. So I'll invite now students to, let's ask questions openly. Apur, you've been through the journey of learning these in depth. So a
Yep.
couple of questions that have come so far, I've pasted, and then we can continue until students have questions for today's session. Appreciate you taking the time and talking about those few use cases of directly applying Apur. So with that, you can perhaps take your question and take on these.
Yeah, sure. Okay, so how to compete amongst peers on DSA? I would rather say you do not have competition with your peers, it's rather yourself. I think if you just focus on your self development every day, if you just put in those grinding those hours, because if you look at it that way, that will look unachievable. Like, how do I compete with someone who is rated this and that on this platform? He has a GSOC rank and all these things. How will I get there? It's not related to that. You have it's your own journey. So you may take X amount of time, other may take Y amount of time, but you know what your goal is, and there's a principle like if you just improve 1% each day, by the end of the year we are like 37 times better. So that's what worked for me as well. Like I come from a tier 3 college, and I was also struggling from all these things when I see when I saw my peers were getting good companies, and how do I crack those things? So it was challenge. So I took that and I did a focused learning. Like there's a next question that how do you think like step by step. So yeah, that's the approach you need to take care of. How do you work on your self growth? So what I did is I took time to learn each and everything in depth. So that's the only way. And with Chat GPT and all these tools, this has become really easy. Like I used to have all kind of crazy questions, how these things work, how that works. And there weren't enough content available. But now you can have any question and it will have an answer for you. You'll have instant answer for it. You'll have diagrams, structures, everything. So it's you have someone because you that itself can act as mentor for you. Like you can have the questions and they will give you all kind of answers, but if you need some guidance, they will always you'll find some peers or seniors they can who can guide you. But yeah, so step by step, like start with simpler data structures like LinkedIn array, queues, tags. So like one step at a time, and then once you have completed those, practice on Geeks for Geeks or Lead Code. So Geeks for Geeks is a good platform if you are focusing on specific kind of company. So they have like curated list of questions for those companies. So they have their own sheet that you can follow. But I would recommend that do not jump into sheets, because what will happen is you'll get demotivated because there will be some hard questions that you may not be able to crack easily. So just focus, like put in hours. It's okay to put in like 1 hour on one problem. I spent one day also on one problem, but that helped me understand the in depth of a problem and the pattern of how these things work. So that's my recommendation. And once you have the simpler data structures done, you can move on to advanced one like dynamic programming, recursions. So yeah, that's the way I would recommend for cracking DSA. And LeetCode is a very good platform. So like any good company, including Fang, 90% questions, I'd say that it comes from it. You'll find it there, and rest is just variation of those problems. So that's the platform that I would recommend to start with.
There is one more question here from Jay Kumar who says, "Can you please state few practical real-world examples of DSA?" So he says, "I understand how developers build application using front end and back end, but where do we actually use DSA?"
Yeah, in my session gave a few examples of how we use those practical examples. Uh, but if you go for data structure, like if you have a problem, like for example, if you want to use hash map, so why hash map? Why not concurrent hash map? So DSA is a tool that can provide you scalability or writing clean code. Yeah. Okay, he's my nephew. Okay, so yeah, I was saying that DSA is a tool. It's not like uh, so if you have to solve a problem, how what tool you want to see use it from your arsenal? Like what is the most effective one? Like you can have multiple options. You can approach your problem with. You will be able to solve it as well. But using the right data structure will help it scale better, and it will eventually be more like the better solution that works efficiently and is scalable. If I use a hash map or like all these things are data structures, like list is a data structure, hash map is a data structure, set is a data structure. So when do you use a list versus when do you use a set? That is also a choice, right? So when you are coding and you are developing something, so it's up to you, right? So if you want to do some lookups, what would you rather use? You would rather use a set to do lookups or a list? Sets, right? Because you can do that in like big of one time complexity. Instantly you can do some lookups. In hash map is again very widely used, like we use it all the time. That works really well for our use cases because you get great lookup time. And other example that I was giving was concurrent hash map. So when we are building when hash map is a single threaded operation, by the way, and you can achieve scale to extent. But if you are building systems where you want some concurrent operations and there are multiple threads cores you're using, so in that case you would like to fully utilize it. Like in Oracle, when we are doing this ingestion, so what we are currently doing is ingesting like millions of records, that's GBs of data every few minutes. So we need to build a system around it. So that's like how do you handle that big data and ingest that data into your system and to a database to be further used for data scientists to put rules on it so that they can do threat detection, threat alert, and these things. So choice is everywhere. Whenever you'll start a project, even for you want to do something like solve the very starting problem of the problem you'll get on lead code is to sum. So that also has like 10 approaches. You can use hash map, you can use for loop, nested for loops. So these things, data structure is everywhere in problem solving. So practicals I was giving like just now, that if you use a graph in case of social, let's say if you go and work in, or if you decide to go work for a startup that is building social network, so what kind of data structures or this request friends and friend request or anything, like we have lots of others, Tinder and all. So these things, all these requests, how do you decide how the flow goes? So how all these things requires data structures. And I had given quite a few examples, so I just don't want to repeat. If you have anything like any particular case, so I can explain about that.
Thank you, Apur. So, as I understand, we will be solving problems on the data. And how do we solve those problems with the data structure we'll be using will be the developer's preference. Is that right?
Yeah, right. So as an engineer, your job is to solve problems. It's what to use when technology comes. Like I would use Java, I would use Python, or I would go with C++. So that's all choices we make. Uh, so yeah, that's like you have to solve the problem. Then you have to choose the technology. Someone would be using, right? I dare say that I'd use MERN stack, Node.js, but you have to decide what technology fits you. It's not important that the latest technology, trending technology, will be like the future and all, because still, if you see, Java is still dominant because of its stability. Because new technologies have a lot of vulnerabilities that we call day zero vulnerability, that comes and all of a sudden everything like gets stopped. So technology is just a tool of solving problem. Similarly, DSA is your choice is which data structure to use to solve your problem. But learning all the data structures is important to know which one fits best for your use case.
Okay, thank you, Apurva.
You're welcome. I hope I answered. If not, you can just nudge me. I'll try to do better.
Folks, you can put in your questions in the poll that is being under your activities tab. Apur, we'll give it 2 or 3 more minutes, and then if there are no other questions, we will be able to wrap up this session. But thank you for the wonderful insights.
Hey, thank you, everyone.
There's one more question from Abir. He says, how should I approach solving problems that seem too complex just at the first glance?
Okay. So how I can share how I try to do such problems. So uh, first is reading the problem very carefully. So if the problem, reading and understanding the problem. So there's a saying that a problem well defined is problem half solved. So if you are able to understand the problem, what it says, and if you are able to just comprehend like what is the ask, what is required, what you have, and what you want. So that if you have that at least in picture, then you can think about how you can do it. Sometimes you also know that, okay, I can do it this way. Like it used to happen that, okay, I see a problem, I see that, okay, I can maybe do it recursively, but recursion was one of my weak points. Like I was not able to imagine, because it's like the bottom up approach. Like you have to break down the problem, go right till the bottom, and then think from the bottom how you will like recursively solve everything, and it gives you a solution. Like such problems I used to find complex. And for these things, what I did is I just dedicatedly solved first with easy recursion problems, so that I get some hands-on experience and understanding of the basics of how recursion works. Once I have developed that, like I did that work on that part of your brain that gets activated, like like it is building muscle of your brain, that okay, I can solve this problem, I can think how recursion works. So then you can gradually go towards a medium problem of the recursion, and then you'll start seeing a pattern, like how it works. Like if it's like mostly trees, like what I get. But yeah, graphs also, like graphs can be done with dynamic approach also. Like dynamic problem is like tabular way of the same thing, but recursion is like more like top down or bottom up. So bottom up, mostly I used to feel how to do it. Even the top down one are also tricky, but yeah. So just solving the easy problem, lots of easy problems, and then going for medium problems. So eventually you will understand how these things work. So once that part is done, then the same complex problem, if you have defined it and have the, like what I have the inputs, what is done required and what is the output, you'd be eventually able to break it down further, like how I can break that middle thing that is left. So that's the way I approach those complex problems. Like you may need help, like I also used to feel stuck at times, but I'd recommend in that case you can always find good content on YouTube. uh, Never like try to copy the solution, always try to understand the process or algorithm, what is the solution for it, like how they are breaking down the problem, like drawing, and if they want to use heap, graph, or recursion, whatever it is, just understand how it works, and then think about it, how you can put it to paper, like put it to code, and that will be the right approach. So that should work. If you just put in good amount of effort, you will be able to then solve those complex problems as well.
Thank you, Apur. Apur, I have a question on behalf of my student. So when the student approached me with this question, he was doing something in backtracking recursion, I suppose. So the challenge he is facing is, hey, I did arrays, then I did all the basic data structures, link list, and then I came here, stack key queues, everything is done. But now at this point, when I look back, I'm not able to solve a doubly linked list or a circular linked list, and I'm way far now. So is there any specific criteria, like you have to do at least this much of this to master it, or is there any divisions among mastering a data structure before moving on?
Okay. That's a very genuine problem, I think, because if I leave some topic for, give it a 6 months or so, if I approach it again, I sometimes get scared, or like I feel, okay, I was able to do it, but now I'm not able to like think about it. So it is a problem. So just one, but after solving one or two problem, like getting some help, I again get the hang of it. So I start to remember and how these things work. So practice is definitely needed, and if you have it for a long time, so it will stay. Like it likes to, like when I was in college, I was also facing this problem that, okay, I understood linked list, but after let's say 6 months or so, if I again look back, I would not be able to solve certain problem. But practice and practice and practice, so that's the only answer. Because if you put enough practice, that will stay. It's as simple as like how everything is around. Like you will eventually forget of what you have learned in college, but if you just go back, remember, read, and then it will again start coming back. So it's all practice. There's no other solution I can suggest for this.
So I don't need to get intimidated looking at it. It's like, yeah, I'm going through the question one or more, two times more, then I will be able to.
Yeah, so I think most of us go through this process, and like I have gone through it. Like, and my friends also who I do competitive coding with them, so that I also like stay in touch. Yeah, so I think that was just nice. So what I do is I challenge them with a certain question that we had solved together, but they also get stuck sometime. They would need some reference. So it's about practice. So you just focus on understanding the concept, solve a few problems, and before interviews, and just do some rigorous practice of some concepts, like few problems from each of these topics. You should be like good with it. You will, once you do it again, like few times, if you do it 3, 4, 5 times, it will stay in your system, like in your memory. So once you start writing it down, it will start coming to you. When you may think you do not remember, but if you just put a little effort, it may start coming to you.
Thank you, Apurva. I'll let my student who asked this also know this. Then there's one more question from Sangesh, reading it for you. I understand the practical example. You say that in social media, but actually in real life industrial, to develop the social media application, they use pre-built data structures.
Right. Yeah, like I was saying that these are not directly applied, but like DSA teaches you the structured thinking. How do you think in what structures? And this is like foundational knowledge to build that system. So yeah, that's correct. Like I also said that even the Dijkstra algorithm that I said that we use for the shortest path algorithm, but it's not like plain Dijkstra. There is, on top of that, there are some like customized Dijkstra or variation of it rather. So it's not directly used. So it may or may not be used in your case as well, wherever you would work. But yeah, it is required. So if you understand the idea is that it will help you understand how to think rather, and how to frame a problem. So let me just read it through your question. Yeah, so I was just trying to give a very like simplified version of the problem and its solution. But yeah, you're right. We do not, like, they also do not use that directly in their solutions. So yeah, that's fair.
There's also one more question where a student is asking, "Hey, if I have an error during dry run, how do we overcome? How do I get when I get stuck during the dry run?"
Overcome. Okay. Okay. So when you're doing a dry run, so dry run, I'm assuming that when you're coding it in interview for interviewer to analyze, is it in paper or in your editor? So anyway, editor or paper. Sorry. So I'm assuming okay, let's assume in an editor that you are doing a dry run and you get stuck during the dry run. So is it like you're talking about an error that you encounter in your code, or how do you, like, I'm not clear on that part. It's your code and you're doing a dry run. So how exactly are you stuck there? I'm not clear on that.
Vignesh? Right, I'll wait for him to make his question even more. He's doing the dry run on a pen and paper before he actually codes.
Okay. So you're doing it on pen and paper, and you find out there is an error. Okay. So if you found out there is an error, then you'd have the idea, like, what's the issue. Uh, like most cases, when we write a solution, the problem is when we do not find an error and we submit a solution and the interviewer finds out, okay, you have put in a bug here. It won't work. That's a problem. So if you already know what the error is, then I'm not able to understand what's the challenge. Like, how do you get stuck in it?
Apurva, I have another question. Meanwhile, Vignesh frames his question in a better way. Like for all of us, this is on behalf of all of us. So if at all we are going to apply for a contest, Lead Code Weekly contest, what should be our initial expectation towards the contest? I find most of our students aiming for some particular ranks and getting disappointed in the first try. So if you can share us some insights on what can we expect in the first round, and
Yeah, I think for if you are like beginners and going for the first time, uh, ranks and all, because see there are lots and lots of great competitive coders, and competing for a like with competitive coders are little difficult because they are doing this thing for years and years. Like that's all, like they do it as a sport. They are very like sharp, and then the codes are also like, if you go through their codes, they have their some solutions are available. If you go through the GSOCs solutions, uh, you'll see that it's very crisp, and the mathematical algorithms they put in it, so you may be able to put solution to it. You may think in a very intuitive way, I will do this and then this should happen, then this, but they would have some kind of mathematical solution that can do it in very like different time complexity, in logarithmic time complexity, or sometimes even constant, because they are putting some mathematical logic in it. And they like I said, they're doing it for years, and their experience level is different compared to college students. So it will be hard to get expect ranks at this point. uh, you can always target to complete the challenges, at least complete and have the all the test cases passed. That should be your goal. uh, like for at least for beginning with, because understand the competitive coders that are out there, and it's a global challenge, I assume, like whatever you're giving on lead code. So there are a lot of people, like some competitive coders in other countries, they start doing this thing from the school, and most of us gets exposed during our colleges. So that's a different kind of segment. uh, like for job interviews and all, you do not require competitive coding, but yeah, these are competitions. They are tough. Like it's hard. Even I do not get good ranks whenever I have done. So yeah, so it's tough. Like it will require lots and lots of practice, and you will have to actually start to see who are the winners and see their solutions. If it's available, you'll find what's the quality. Like it's in a like really crisp and something out of the box solutions you'll find, that you will not find it conventional. That's why they are like on top. So yeah, I would recommend that if you are disappointed, just go through the solutions of the leaders. So that will help you.
thank you, Apurv. I think there's one last question before we wind up. So Jay Kumar is again asking, how do we find out hidden test cases? Is there any trick to identify hidden test cases?
I haven't found. If you find, you can help me, because these are like they're on their own servers and they are not exposed, so you can't find. Only thing is that if you know that your test cases are failing, so think about the part where it can fail. Like you have some few test cases, you see that they are working, you know that till what point they might be working, or what are the limitations in your code. Is it the range? Like what if the value that you generate, it goes beyond certain number, or that's not handled in your code. Like it can turn to signed to unsigned, unsigned to signed. These things can happen. That is like one of the common errors that I used to find during my case. But on more complex problems, that looks, the solution looks to fit the test cases, but it doesn't fit the all the test cases. So those are uh, the ones that you need to put deeper thought and come up with like if you just put in some time into thinking like where it can break. Like you go through the code and your examples and see that what is the point at which it doesn't go well, like it doesn't fit there. So that you have to come up with your own test cases to challenge your code in order to like overcome those failing hidden test cases. That's the I don't think there is any trick to get those hidden test cases. At least I don't know.
Oh, thank you, Apurv. So I think we don't have any other questions. If we have any other questions, you can ask it. We still have a minute. Thank you so much, Apurv. It was a very thought-provoking session that you have delivered, and I'm sure everyone here, they would have walked away with more deeper understanding of data structures that we use every day. Thank you so much.
Thank you. It was very nice having a session with you all. I hope I was able to give some insight. So thank you.
Yeah, I think we can wrap up this session. Really, thank you so much, Apurv, for this.
Okay, sure. Thank you, everyone. If you want to connect, you can connect